Before I start, I want to thank Codesmith as well as Jeeny and Bractlet for sponsoring this tech talk. My name is Mariko Iwata, and this talk is on TypeScript. And so in this talk, I'm going to discuss what TypeScript is and why it came about, the benefits of using TypeScript, as well as some pitfalls. So TypeScript is a language for application-scale JavaScript development. It's a typed superset of JavaScript that compiles to plain JS. In other words, it's syntactic sugar built on top of JavaScript that allows you to write and generate JavaScript code that acts more strongly typed and object-oriented. To get a sense of where TypeScript fits in the long timeline of JavaScript that where it was initially released in 1995 as Mocha and then submitted to ECMA as JavaScript by Netscape in 1996, here's a timeline of when it all started for TypeScript. It launched in 2012 by Microsoft, and it was in a time when jQuery was king. It was pre-ES6, pre-ES5, and there came a need to write large-scale web applications. And JavaScript at that time, as is, couldn't really do that. So Microsoft created TypeScript, a language for an application scale JavaScript development. And this was a reaction to the need for more robust tooling for web apps that are going to have to be in JavaScript, considering the robust ecosystem JavaScript had come to have. And that said, just because Microsoft made it and had its valid reasons, it's not inevitable that it would be as popular as it is today. So you can see here the term TypeScript is searched over 800,000 times a month on Google. YouTube has endless tutorials on it. And if the guy from Algo Expert is talking about it, it must be relevant, right? And here's some more fuel to the fire. No doubt TypeScript is popular. It's been gaining popularity since 2017, rising from the 10th most popular language on GitHub to the 4th in 2022. And this is according to GitHub's State of the Open Source software that it releases each year. And then also, not surprisingly, the growth in use was 36.8% from 2001 to 2002. And it has weekly downloads as an NPM package of more than 40 million. But why is it so popular, right? And to answer this, I want to go over 5 benefits of TypeScript from a developer standpoint. So number 1, there's optional static typing. Now, what is static typing? A statically typed language is a language where variables are known to compile variables are known at compile time. So with TypeScript, you can have your type checked at compile time, for example, within your IDE like VS Code. And rather than runtime after it's on your local host, for example, where we've all seen the type error listed here in red, cannot read properties of undefined. So being statically typed is beneficial because you don't have to wait to see when your error. It can be fixed before it's run on the browser. The second benefit is less debugging. So with static typing and declaring the type within your code, you can address some of the frustrations out there that we all have with JavaScript. For example, none of the type coercions in the screenshot you see on the left will throw an error in your code with JavaScript, but it would in TypeScript, so you can catch them rather than finding them down the line. A third benefit to TypeScript is the compiler feature. So basically, as JavaScript evolves, if a browser didn't yet support optional chaining, for example, with TypeScript, you can still use it because it will compile to a version that runs in all browsers. The fourth benefit is type inference. In the example to the right, you see how the JavaScript file doesn't show any errors, even though the second line is a number. But for the TypeScript file on the bottom, there's an implicit type that the name is a string. And then later on, when it's assigned, another value is, the value is underlined in red because it's showing that it's an error. So you don't have to jump back and forth between files to see the type that you had in your functions. And also another point is it's easier to convince developers to use a more static type language and move away from legacy stacks in favor of new stacks such as React. And the fifth benefit is incremental adoption. Your JavaScript code will run alongside TypeScript. So this means that you can slowly deploy changes to your app. There's no bottleneck where you have to finish all the conversion for it to work and to deploy. And one more reason is that many companies use it, like Reddit, Slack, Asana, GitHub, and Lyft. And Airbnb did a study and concluded that almost 40% of their code errors could have been avoided if they used TypeScript. So there's a lot of reasons here to use TypeScript. That said, these benefits don't come without pitfalls, and everything has a trade-off. So we have to weigh the good and the bad before we jump in and convert our code. One pitfall is extra complexity, even for simple tasks, and I'll show an example. The second is error messages. They can be difficult to understand at times. And the third is slower build. So let's look into the extra complexity. Can everybody see my VS Code? Okay, cool. So in the first part here, you can see this is a TypeScript file, and you can declare an object similar to how JavaScript would declare an object here. And basically the type is inferred. So if I reassign the key name in the user object to something like a number, you'll see that because it's TypeScript, it's going to tell me that it's wrong, that I need to change it to a string. So I'll move it back here. So that's one, that way you would actually, you could write JavaScript that way, and TypeScript as well, but the complexity comes in the other ways that you can declare types. So here, I have an example where you're explicitly describing the object using an interface declaration. So if I were to then use that interface here and have this object conform to the shape of the interface, I'm following the structure. So I'm following the name, the ID, and the name is a type of a string, and the ID is a type of a number. And if I don't do that here, where I don't have the key as a name, it'll actually throw an error for me. And so you see that there's this extra complexity. There's also other ways to make complex types by combining simple ones through unions and generics. There's also a concept of a structural type system, and the list goes on, making it complex if you are just trying to make a simple app. The next piece here is simple type errors are usually easy to understand, like the one I showed you. But sometimes TypeScript produces error messages that are unhelpful at best and unpredictable at worst. And here's an example on Reddit where the error was long and only the piece that is underlined in red was really necessary to solve the problem. And lastly, type checking can slow down the build process, especially in a large project. So if you're running a development server that reloads on code changes, the slow TypeScript build step can slow down your development as you wait for the code to build. There are some ways around this. Instead of using TypeScript, you can use a compiler and things of that sort. But all in all, it's definitely something that has been an issue using TypeScript. And that is it for my talk. Here are my sources for the Tech Talk. And thank you for joining me. My contact information is here on the slide. Please reach out if you have any questions.